this topic. I want to emphasize this topic, mathematical representation. Yeah. This is a very basic problem. So many problems we need to do this mathematical representation. So given a problem, how do you represent it mathematically or in a good way? So if you represent in a very good way, so you can solve it easier. Yeah. So let's see. What's the string matching problem? Given a string of n characters, we call text. Okay. A block, a text, string, a long string. Okay. Could be a long string. Okay. And another string of m characters, we call a pattern. Pattern, smaller. Okay. M less than or equal to n. Smaller than n. Now we want to see, can we find a portion or a segment in the test that match the pattern exactly, match the whole pattern exactly. Okay? So we want to solve that problem. Find a substring of the text, substring, that matches the pattern. Okay? We need to find the location of that substring. Okay? So what do you mean that its location? The left index I of the index I of the leftmost character. Yeah. Yeah. So. Yeah. So yeah. Start from there. M characters, M consecutive characters. Yeah. So that's you match the pattern. That's simple. Yeah.
Are we assuming there's not duplicates of the M? So like just first one it'll go back and first multiple. So
multiple. Even the duplicates, you need to match the pattern exactly. So pattern, do you have duplicate characters in your pattern?
No, I'm saying if the pattern matches multiple places.
Oh, multiple. Yeah. Right. Good. Yeah. The first one. Yeah. Yeah. First one is one solution, but another solution you need to find all the patterns. Yeah. All. Yeah. You shift, still you get still okay. Yeah. So that's typically these two types of solutions. Yeah. But it seems for this one we just return the first one. Yeah. First one. Yeah. All right. First solution. Yeah. Remember the topic of this lecture is called a brute force. So we use brute force method to solve it. Okay? Because later, you will see there is a very smart, efficient algorithm to solve this problem. So later we will come back to solve it again using a much better way to solve it, an advanced algorithm. First, we just use the direct way. Right? Yeah. Let's compare one by one. Brute force. Yeah. All right. Straightforward thinking. Yeah. That's the brute force. But we need to have its mathematical representation first. Here, the words, so the problem given in words, there is no math formula there. If there is no math formula, how do you solve it? Right? So that's why the mathematical representation is important. You want to represent in math formulas, symbols, notations, abstractions. Then you can use math tools to solve. Okay? Also help you thinking. Yeah. In words, how can you solve? In words, right? How do we think in words? So you will feel very hard. Okay. So that's why representation very important. Okay. All right. Text. Let's represent text first. Okay? Can we represent in this way? Okay? Each character we use one symbol or notation, but also we use the subscript to mark the locations, indexes. Right? That's a simple representation. Okay? Yeah. Similarly, for the pattern, we represent in a similar way. Okay? Just like an array. Okay? Just like an array. Yeah. All right. Then, when we do comparison, we compare character with character for different locations. Okay? Yeah. All right. Requirement. Now, we translate requirement from the original problem to math expressions. Find the location I such that Ti equals P0. I somewhere in the middle, that one matches the first character in the pattern. Then, consecutive character matching comparison. Okay? Yeah. From I, you go J positions. Here from 0, you also go J positions. Right? Yeah. Same. Now, I plus J compare P sub J. And the last one, I plus M minus 1. Minus 1. Yeah, because the first one, I plus 0. Okay? I plus 0. The last one, I plus M minus 1. Okay? Here, M minus 1. Okay? Yeah. So that's our math representation. So, or translation. So you do some equivalent translation. But in this language, you can get an idea. You feel it's much easier for thinking, right? Yeah. You want to do thinking. See, it's much easier to do thinking. Okay? Yeah. All right. Thinking for a solution. Yeah. So I think we are pretty close to get a solution here. Okay. Thinking. Okay. No. Every time extract an M substring. Now here, let's just call a substring with M consecutive characters. We call it M substring. Okay? From the text with consecutive characters. Right? Compare it with the pattern for a possible match. Right? How can we exhaust all such M substrings? Yes, we can exhaust. Okay? So then, we will go through all the possible M substrings. Okay? Yeah. That's the brute force. That's the brute force. Yeah. Or we can also call exhaustive search. Because we exhaust all the cases, all the possible cases. We also call exhaustive search. Now, so next we have another question related to the exhaustive search. Right? How many such M substrings? Well, we want to look at the efficiency. How many comparisons? How many character comparisons? We want to count that number. Number of character comparisons. So we need to know this. How many such M substrings? Yeah. Calculate that. Yeah. All right. Guess and verify. Yeah. Although that number is not hard to get. But here, let's apply this guess and verify approach. We guess first. But when we guess, it's very likely it is not very precise. We may miss a little bit. Okay? So after that, because our guess may not be very precise, we need to make some adjustment to make it precise. Here, we use that way. Let's make our guess. Okay. Based on the problem, now I think you understand the problem completely. So based on your understanding, can you guess approximately how many M substrings do we have? You move from beginning to the end, right? You start from the first substring. Then n minus something. N minus what? M. Good. That's a really good guess. N minus m. This is a very good guess. Yeah, because that long, that you already occupy a lot of, positions. Then you shift. Okay? So approximately m minus m. Yeah. But the question is, this guess may not be very precise. Yeah. We may miss a little bit. It's very likely we miss a little bit. So we need to find that little thing and we adjust it to make it precise. Yeah. So that's what we need to do. So after this guess, we need to verify it. Is this how much it misses our goal? Okay. We need to verify it. Okay. How to verify? Very simple. How to verify? Oh, sorry. How to verify? Let's consider special case. Okay. When m equals n. Yeah. When m equals n, you need to complete at least once, right? Yeah. But this number 0 does not match 1. So you need to make an adjustment, right? Plus 1. Right? Yeah. So you can easily see. Answer is n minus m plus 1. That's simple. Okay? That's simple. You need to verify it. You need to make adjustment. Find a very special case, trivial case. Trivial. Yeah. So your guess should be correct even for that trivial case. But 0, not correct. So you add a 1. That's simple. Yeah. See? Yeah. All right. This is the correct answer. Yeah. All right. Next, implementation details. Yeah. All right. Now, we want to do comparison. One by one, substring comparison. Okay? One after another. Oh, by the way, so last time, remember? So we talked about left shift, right shift operation, right? So one student mentioned, so I searched the web, so that student was correct. So left shift, right? Division, when we do division, right? Yeah, division, right shift by 1 position. All right, because I see, we will do shift here, right? Yeah. All right. Our first m substring, like this. Last m substring is this one. Okay? All right. Now, for this last substring, what is the subscript? Can we figure out what is the subscript? Right? It looks like we need to do some calculation. Yes, yeah. But how confident you are, right? N minus m plus 1. Okay? How confident you are, right? So here, let me use another way to explain it. Yeah, the answer is correct, right? Yeah. The same as our answer, the number of m substrings. Yeah, same answer. Okay? But here, I want to show you another way to see it. Yeah. Also, yeah, because this method we use many times, so I want to practice another time. Okay. You can see for this class, several methods we used again and again, many times. So I hope you eventually you can learn all those methods, commonly used methods. Here, that method we use more than once already. Okay? Here, how to figure out this subscript. Let's just use x. Okay? Let's put x there. We try to find x. Here, we use that invariant idea. Remember, invariant idea we use many, many times. Okay? So here, let's use that invariant idea another time. Okay. What's that? This time the invariant. We want to look at the difference of two n subscripts. Difference of two n subscripts. That difference, when you move, when you shift, that difference should be the same, right? Yeah, because the same length, you shift, no matter where you shift, that difference of two n subscripts must be invariant. Must be invariant. So we use that to fix that x subscript. Okay? All right. So for the first string, substring, that's m minus 1. For the last one, the difference, this is x, m minus 1 minus x should be equal to m minus 1. So we get this equation. Okay? So we solve it for x. Oh, a minus m, not plus 1. Yeah. So here you can see. Okay? Yeah, because when you base on your intuition, whatever, guess to your intuition, sometimes you may not be correct. So here, let's try another different way to do it. Yeah, we solve, we find this subscript should be equal to n minus m. Okay? Invariant, using that invariant thinking. Yeah, so you can see, very important. Okay? Yeah. We use this many, many times. Invariant. Okay? Yeah. All right. Now we can implement. So the first substring location I equals 0. The last m substring, the location I equals m minus m. So we can do scan. Okay? Well, we can scan. Okay? Run this I from 0 to n minus m. Okay, so compare the selected m string with the pattern. Okay? Yeah. So we use a for loop. Compare, character by character. Okay? The pattern character at j and text character at I plus j. Okay? And we want to get correct comparison for all j. Then it's a match. So we get a match. Okay? Yeah. So that's simple. Yeah. So that's the brute force. Straightforward. All right. Next. True, we need this comparison true for m comparisons. If one false, we should get out of the for loop immediately. We do not need to go to the next comparison. If one, you miss one, then this selected m string cannot be a match. So you should stop immediately. Don't waste more comparisons. Okay. All right, so pseudocode. Yeah. Pseudocode, the first version, yeah, just based on our understanding, the first version. Okay. We start from, yeah. Oh, this is not right. Yeah, I need to fix that. Because I from 0 to n minus 1, right? Not n. Yeah. Because after this, we don't need to go to the end, right? Yeah. So definitely we need to stop at m minus m. Yeah. Yeah. All right. After that, okay, internally, No, all right. Not equal, okay? Not equal, no match. Okay? Oh. If not equal, right? If not equal, then it's no match. So we break. We get out of for loop immediately. Okay? All right. Then at the end, we check if the match, no match variable equals 0 or not. If it equals 0, then we find a position. Okay? Matching position. Right. All right. But there is another version, similar to this one. We use a while loop to represent this for loop with break, because the comparison we put in the while comparison condition. Okay? If no match, you get out of while loop immediately. Right? So this is another good way. So at the end, you want to compare if your J reach M or not. Yeah? Your J reach M, that means you get all comparisons, all correct, all matching comparisons. Yeah. So, all right. So the code is very simple. Yeah. But we know this is the brute force method. And we know usually it's not efficient. Yeah. Not very efficient. Yeah. So, yeah. We know the string matching problem, very fundamental. In the real world applications, it is fundamental. Yeah. Question?
Is it supposed to be n-1 on the right side?
Correct. Yes. Yeah. Should be the same. Yeah. Yeah. I need to change. Yeah. So yeah. Hope you put on your notes. Yeah. Right. So yeah. Good. All right. Yeah. Efficiency analysis. Worst case, best case. The best case. Yeah. Best case, we only do one comparison and we get a match, right? Yeah, that's best case. So we stop. Yeah. We compare the first substring, okay? We find a match, we stop. That's the best case efficiency. Yeah. But in that case, you need to compare all these M characters. So M comparisons. Yeah. The worst case, you need to go to the end. Okay? Compare all the characters. Right. Times the number of M times the number of substrings, M substrings. Yeah. That's easy. So what is the average case efficiency? Is it average of these two numbers? Usually you should be very careful, but here the answer is correct. Yeah. Because you can try. So you can try this. M, another case, 2M, right? Another 3M, all the way to this multiple of M. Then you add up, divided by these numbers, you get this number. Plus 2, okay? Because you have 1 here plus that 1, so you get 2. Then divided by 2. You still get that. Okay? So the average case efficiency. When we do that, we should be very careful. Yeah. 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 Sometimes you can do two numbers adding together divided by 2. Sometimes you cannot. Okay? Yeah. Yeah. All right. Oh, yeah, just a minute. Yeah. So we finished this problem. Oh, we finished the first solution of this problem. Yeah. Because later, this, as I said, it is a fundamental, string matching fundamental problem in real-world applications. So we want to learn a more advanced, more efficient algorithm for this problem in this class. Yeah, definitely we need to learn that. Okay, yeah. Because we can compare. How can we improve the performance significantly? Yeah. Because here, when we look at our algorithm, we couldn't see why it is not good enough. We couldn't see, right? We try the best we can, why this is not a good one. Not easy to see that. Yeah. Yeah. All right, think about it. Yeah.